You can title these notes Energy of the Electrons. Yesterday we had talked about how to calculate the wavelength and the frequency. Today we're going to continue to use those concepts in two additional formulas. E is equal to HV, and E is equal to HC over lambda. Now let's identify your major players in these formula. What do you suspect the C stands for? What does lambda still mean? Very good, the wavelength. 1, what does the V still stand for? Very good. Now, based on the title of your notes, what do you suspect your E is standing for? Okay, so E is going to be for energy. And this E is going to be for energy as well. So the only guy here that's new, really, is going to be your H. And that's a constant value we have to describe. And that's going to be called Planck's constant. A value that is a value that is never changing, a value that is static. So let's go over it. This H stands for Planck's constant. And since it's a constant, I have to go over its value. So the H constant has a value of 6.626 times 10 to the negative 34. And that's a constant. Again, that's Planck's constant. A value that never, ever, ever will change. 6.626 times 10 to the negative 34. Now with your homework out, the homework that you have, let's look at that top problem. What did they give you on that top problem from last night? They gave you the wavelength, right? What was the wavelength of that first problem? 5.68 times 10 to the negative 5, right? Centimeters. And in that third column, what are you supposed to find? No. Look at the first problem, guys. Third column, you're supposed to find energy, right? Right? In joules. What do they give you? Wavelength. So which formula should we be choosing to use? The left one or the right one? Why the right one? Jennifer, why would you choose the right one? The wavelength? What's the unit of the wavelength? Meters? We choose the right one. E is equal to HC over lambda. Now, what does our wavelength need to be in? Meters. Is it? So what should we do with that first problem? Very good. Convert from centimeters to meters. 5.68 times 10 to the negative 5 divided by 100. 5.68 times 10 to the negative 7 meters. Convert that to meters real quick. Now this is the formula we're using. What are we supposed to be finding, everyone?